Today we're going to learn about motion, or speed and accelerations in specific. Okay? So in general, motion is just a change in position over time. Okay? So if you start one spot and in another, you measure that time, you can figure out, well, that of course that's movement or motion. Okay? It's all around us, of course. There is a difference between distance, which is how far something moves, and its displacement, and that's its distance from the starting spot. So for example, you take someone running on a track, nice oval track here. It's 400 meters around that track. If I start here and I run, okay, and I make it all the way around the track, the distance I've traveled, of course, is 400 meters. Okay, but my displacement, if I come back to that exact same spot, my displacement would be 0. All right? So there is that difference in size between distance and displacement. So make sure you note that. Okay, so today we're going to primarily talk about speed or velocity. Okay, so speed is distance per time, okay, which is going to be used interchangeably with velocity for our class. Okay, technically, velocity is speed and a direction. All right, so we'll kind of use this interchangeably, and the symbol used for velocity is v. But velocity is simply distance over time. Okay, so you measure a certain distance and measure the time, you can determine what its velocity is. Okay, so for example, if we want to know how fast a runner is running, okay, so we know that distance. We know the distance is 400 meters, and we time that individual. And let's say they do it in 50 seconds. Okay, we can figure out the velocity. So velocity would just simply be, okay, distance over time. So distance over time. So the distance would be 400 meters, and the time would be 50 seconds. And if you do the math on that, it comes out to be 8 meters per second. Okay, so in science, okay, and in the world, we use what is called the System International, or the metric system, International System Measurement. Distance in the metric system is measured with the base unit of a meter, which is a meter stick. Okay? Some of you, of course, being Americans, have yardsticks. Yardsticks are a little bit shorter, about the same length, but a meter is a little bit longer. Okay, so that's the base unit. And then for time, the base unit is the second. Right, so those are the two units we use them most often for velocity. Okay, but we can use other units too. Okay, so 8 meters per second. And let's say you could do that for 4 minutes. Okay, so the time, 4 minutes. Now, you have a bit of a problem here if we want to figure out what distance you could go if you know the speed and the time. Okay. Distance would equal velocity times time. Formula here. Distance is velocity times time. Okay? So I take that velocity, which is 8 meters per second, times the time, which is 4 minutes. But now here's a bit of a problem. If I do that, we mix up units. Got seconds here, minutes here. Okay? For this to come out to be in meters, we have to change that into seconds. All right? So 4 minutes is the same as 240 seconds. Okay? You can do the calculator on that, but 60 seconds per minute, so 60 times 4, make sure I did that right, is 240. So it's 240 seconds. If that runner could do that at 8 meters per second for 240 seconds, he will have traveled 1,920 meters, which a lot of times you wouldn't use that. You would say that's about 1.92 kilometers. In the metric system, we just have to change the decimal. Since there's 1,000 meters in a kilometer, it would be 1.92 kilometers. Okay. A mile is about 1.6 kilometers. That would mean this guy could do that, he could break that 4-minute mile, which is a standard in track and field. Right? So If you know the velocity and know time, you can figure out the distance. Okay? By the same token, if you know distance and velocity, you can figure out the time. Okay? And this is good for estimating. For example, if I wanted to go down to Eugene to see a Duck game, okay, I want to know how long it's going to take me. And I know the distance. I'm going to go back to the English just because we use miles. It's about 150 miles from here. Okay? And if I know I can travel on average 50 miles per hour. At some points I can be going faster than that. At some points I'll be going slower than that. But let's say average 50 miles an hour. I can determine about how long it's going to take me. Okay, so if I take 150 divided by 50, that comes out to be 3 hours. Miles cancels out. So it's going to take me about 3 hours to get down to Eugene, okay, if I can average it 50 miles per hour. So that's quite useful. And the last concept I want to talk about today is this thing called acceleration. Acceleration is a change in speed. Okay? So accelerations occur when forces are put upon an object. Okay, for example, if I have this marker right here, okay, if I let go of it, okay, it will drop to the ground. Okay, but the force of gravity is pulling it down. It causes it to accelerate. Okay? But cars, you can see here, when it goes from 0 to 50 in 2 seconds. Well, we can plug those numbers in. Let's say it's 0 to 50 meters per second in 2 seconds. Well, acceleration is change in velocity over change in time. Okay, in science, they use this little triangle to mean change in. Okay, so change in velocity, so it goes from 0 to 50. Okay, so it would be 50 meters per second. And we said it takes 2 seconds to do that. So if you take 50 divided by 2, that comes out to be 25 meters per second. So that means every second it's moving 25 meters per second faster. All right? So you can actually abbreviate that to 25 meters per second squared.